Welcome to Python, Handling Missing Values and Imputation. In this lesson, you will discover how to handle missing data in Python using simple tools. Missing values are common in real-world datasets, especially in data science. By the end, you will know how to find, understand, and fix missing data, important skills for any project. Let us get started. Running the cell now. What are missing values? Missing values mean some information is not recorded in the data. Common symbols for missing data include nan, which means not a number, none, or empty cells. We need to handle missing values before we can analyze or model our data. Running the cell now. Let us start by setting up our coding environment. This line is a comment describing what the cell is for. Here we import a warnings library to manage warning messages that pop up as we code. This line will make the warnings stay hidden so our output is cleaner. Now, we import pandas and numpy. Pandas is a tool for handling data in tables. Numpy handles numbers and missing values. Running the cell now. Can you name another library often used in data science with pandas and numpy? Data setup. We will use the Titanic dataset for this lesson. It is a real dataset with missing values. You will learn to load, explore, and work with it step by step. Running the cell now. Now we will load a real dataset. This comment shows our intent to load Titanic data from the internet. We define the URL for the data file as a string. We use pandas to read the CSV file into a variable called df. That stands for data frame, a table of data. This line shows the shape of the data, how many rows and columns we have. Here we display the first few rows so you get a feel for the actual data. Running the cell now. Try to spot any missing or odd values in the previewed data above. Let us check which columns have missing data. This comment tells us what the next code does. Here, pandas checks for missing values and gives a count for each column. Running the cell now. Which columns have the highest number of missing entries? Now, let us see what % of each column is missing. This comment summarizes what happens next. Here, we find the average of missing values, multiply by 100 for %, then round the results for easier reading. Running the cell now. Why is it important to know the percentage, not just the count? Let us look at some examples with missing values. Our comment tells us we will focus on rows with missing data. This code picks out and shows rows where any value is missing in that row. Running the cell now. Look for patterns. Is missing data random, or do you see anything in common? Let us make a visual chart to show missing data. This comment explains we will make a bar chart. Here we import matplotlib, a library for drawing charts. This line creates a bar plot of missing value counts, 1 bar for each column. Now we add a title to the chart. The label explains the y-axis shows count of missing values. This displays the chart below for you to see. Running the cell now. Which columns need the most attention in cleaning and why? Main ways to handle missing values. 1. Remove rows or columns with missing data. 2. Fill in missing data, which is called imputation. Which method to use depends on your data and your goals. Running the cell now. Let us try removing all rows that have any missing data. This comment tells us what the block will do. We use dropner to make a new data frame that drops all rows with missing values. This line prints out the old shape so you can compare. Here we print the new shape after dropping some rows. Running the cell now. Why might we not always want to drop rows with missing values? Sometimes it is better to drop columns instead of rows. This comment tells us we want to drop columns if they have too much missing data. We set a threshold for minimum non-missing values per column. Anything below 60% will be dropped. Drop no with axis equals 1 drops columns, not rows. Thresh tells it the cutoff. Now we check the new shape after removing those columns. Running the cell now. When would dropping columns make more sense than dropping rows? Now let us try filling in a missing value using something called imputation. Here we will fill missing ages by using the average age in the column. First, we calculate the mean, or average, age. Here we make a new column with all missing ages filled with this average. This line shows both the original age and the new filled age for a few people. Running the cell now. What are possible drawbacks to mean imputation in real scenarios? Let us fill in missing places of embarkation with the most common spot. We call this mode imputation. Mode means the value that appears the most. First, find the most common place someone got on the ship. Now, fill all missing embarked spots with this value in a new column. Show both the original and filled values for a quick check. Running the cell now. Why is it sometimes better to use the mode instead of the mean for filling categorical values? Forward fill is another way to fill missing values using the entry above. This block will show how forward fill works. In this method, pandas copies the previous value down into the missing spot. Let us compare the old and new columns after filling. Running the cell now. Where do you think forward filling works well in real-life data? Next up is interpolation, finding a value using numbers before and after the missing spot. We use interpolation when our data is ordered and numeric. This function guesses a missing value based on its neighbors. Let us see the effect on the age column side by side. Running the cell now. Try to explain in your own words how interpolation might be helpful. We can also use tools from a library called scikit-learn for more control. Now we bring in SimpleImputer, a helper that handles missing data for you. Here we choose median as a strategy, which is good for numbers with outliers. SimpleImputer will fit itself to the column and learn the median. Now it fills missing ages with this median, making a new column. Let us glance at the results for a few people. Running the cell now. When might the median be better than the mean for imputation? Let us confirm that the age column is now fully filled after using SimpleImputer. This block checks if we still have any missing data in age_median. We expect 0 here, which means all missing ages are fixed. Running the cell now. Have you fixed every missing value, or are there other columns left to impute? Let us practice choosing a value for a missing age ourselves. This cell asks you to enter what you think is a good replacement age. Input waits for you to type in a value for practice. Now we print out your idea so you can see what was chosen. Running the cell now. Think about when you would use your own judgment versus a function like mean or median. Want to support our YouTube? Please like the video and try it along with us. Let us do a mini project together. In this challenge, you will combine dropping and filling methods. First, remove every row with a missing embarked value. Then, find the median age in this clean dataset. Fill any missing values in age with the median you just found. Print out missing value counts for every column, so we can see what is still left. This final check will help ensure our cleaning steps were effective. Running the cell now. Does your clean data still have any missing values? Try to explain why. Now let us see if handling missing values changed our result. First, we measure what % survived in the original data. Then, we measure % survived in the clean data. Now we print both values for a side-by-side comparison. Look closely for changes. Did cleaning the data shift the outcome? Details like this can impact your final analysis in real-world projects. Running the cell now. Try to explain why the survival rate changed or did not change. Share your answer in the comments. Troubleshooting common problems. If your data does not load, check the URL or file path. If filling methods throw errors, make sure you type the correct column names. For big datasets, imputation can take time. Be patient. Running the cell now. Sometimes it is useful to know which values were filled in. This comment introduces flagging rows that were changed. We create a new column that is true if the original age was missing. Then, we fill the missing age values with the mean in a new column. Display a few rows, showing the original, filled, and indicator columns. Running the cell now. How might this information help you during data analysis? Here is a small challenge exercise for you. This time, we ask you to pick any age you want as the replacement. Input will wait for you to type a number, which will be used to fill missing values. This puts the value you entered anywhere an age was missing. We show the before and after columns so you can see the result. Running the cell now. Share your result or idea in the YouTube comments. Do not forget to subscribe if this helped you. Try using another value to see how it changes the data. Recap. In this lesson, you learn to detect missing data, remove or fill missing values in several ways, use mean, median, mode, and your own ideas for imputation, spot the effects of data cleaning. You are now ready to work with real-world datasets with confidence. Running the cell now. Want more beginner Python? Like and subscribe to our channel for more practical tutorials. Comment below, what topic should we cover next? Running the cell now.